Our next paper is a review of deep learning model for reliable handwriting signature authentication presented by Mohammad Hussefa. Please come on, guys.
Right, right.
Good afternoon. My name is Mohammad Hussefa and I am a student from CS&IT and my title is Review of the Learning Model for Handwritten Signature Authentication. This is the index, abstract, introduction, literature review, research guide, purpose, methodology, result and discussion, conclusion, feature or difference. This is abstract. Handwritten signature verification is like that uses the legal document for banking and security system. Legal document like that any property and any loan agreement and security system like that any banking system and authentication for online transaction. And in signature verification for image analysis we use the scanned paper and scanned paper based. And then will be for facing to the problem two things. First is small image size data and second is identify the forgeries. And then solving the problem like that use the machine learning model like that CNN and CaptionNet. And in machine learning model VGG 16, VGG 19 and CaptionNet. Introduction is like the two methods like that online handwritten signature verification. This is the dynamic and offline handwritten signature. But my topic is offline. So then online will be offline is a very challenges as compared to online because scan the image and every pattern recognize like that a pattern and angle and like that horizontal vertically checking for through model. And then data augmentation technique will use for cycle gate. Data augmentation technique like that will use for the increase the data image size and improve the performance of the model. I have already 50 paper reviewed, then some added is like the 19 paper added. So first is deep learning, we will use the CNN model, CaptionNet CNN model, and second use the CNN. Research rigor, first is data size and diversity. Main problem is limited data size. So for solving the limited data size, we'll use the data augmentation technique with cycle gate. Then we'll increase the data size. And second is the variability in handwriting style. And third is data augmentation technique and what is real-time verification. And this is the methodology. First take the data set to a random. Not this way. Take a data set like that CYT, CDAR data set through a paper. Then we will do use technique data pre-processing like that technique scale conversion, resizing, finalization and normalization. And then we do the split in two parts, testing data set and training data set. I take and 30% testing data set. And then we will use the applied deep learning model CS&IT and BG19.
Outside my bag and laptop.
Data is printing in data preprocessing through apply the grayscale. Grayscale the color image to convert into grayscale and reduce the time complexity. And then we will use the normalization. Normalization used to reduce the redundancy, and resizing will be used for the unnecessary space. Then we will move to.
Why not dance next? Dance next.
Please give, we'll take questions after his presentation. Let him complete.
This is the result through a SEDA dataset and PDS and CYT.
Same data set, different models, what it is.
Actually, I take SEDA dataset.
And the handwriting samples, source and
Writing.
what was the specific problem that literally troubled the model?
Double is two things, data set size problem. Actually, limited data size was good, but large data size apply, so some reduce the accuracy is less as compared to less data size.
Size of the image was
224.
24, right? And it's a RGB or grayscale?
RGB
It's
they
not
convert into the
that reduced to how much?
120.
Filter sizes?
Data size is
Not to depict that, sir. That is the work that you are doing, isn't it? This is the architecture. You have to show that diagram. How is the reduction for the image?
There is any question from the audience?
First of all, why you had asked the performance evaluation of some CNN retrained model.
actually CNN is good work in image
I mean, you had on the performance evaluation,
yeah.
of some pre-trained CNN model. You had used it for the yeah, and right.
Yeah.
So I want to ask you why you don't have made the comparison with DevSnets. Why you ignore DevSnets? What is the reason?
Actually,
We had DevSnets as well, and DevSnets perform very well on some data
as
sets.
compared to other.
You have a hand recognition, yeah? We had a large, huge amount of data available on handwritten, such as and this so DevSnets can perform very well on those data.
Actually, I work on CNN and BG60 model.
Okay, thank you.
Okay, thank you.
Thank you, Zephyr. Let's move to our next paper. Paper ID 39, Virtual Fencing of Security, a Comprehensive Review, presented by Mohammad Nasir. Please come on next.
Yeah, good afternoon to all of you. This is Dr. Mohammed Nasir, and today I am going to present my research work, that is virtual fencing for security, a comprehensive review. So actually this is part of a project sponsored by TST. The title of our project is Virtual Security System in Remotely Located Educational Institution. So from that this idea comes, because for virtual security we are using virtual fencing. So before we start, this is our index of our PPT. First I will cover the abstract, their introduction. Then after that we cover how virtual fencing evaluate. Then I will cover various types of virtual fencing technologies and core technologies, application domains, and etc. So what is virtual fencing? Actually problem is there are two different words, virtual and fencing. So if you talk about virtual, this is used for security. So if you talk about security, first thing that comes in our mind is computer security, or network security, or security related to our banks. Okay. And if you talk about fencing, so we are thinking about physical fencing, just like metal sheet, concrete wall. But this is not both of these. Okay. This is virtual fencing. Here we are not talking about computer security, here we are talking about physical security. And fencing, here we are talking about not physical fencing, here we are talking about virtual fencing. Okay. So virtual fencing is a new approach to secure infrastructure using advanced technology to create dynamic intelligent boundary system. This is used basically for military application, this is used for critical infrastructures. So in this paper, we will discuss various technologies related to virtual fencing, as well as we will also discuss the application of virtual fencing. So when we talk about security, so security is a human concern from starting of human civilization. Okay. So here fence always means physical fence, just like wooden plank, metal mesh, concrete wall. But in the age of today's computer technology, the traditional concept of fencing has changed. Now we are using various computer technologies to solve this kind of problem. So if we are using the virtual fencing, we have following advantages. Here we can monitor boundaries without human intervention. Just like remote location, we can talk about countries. We can talk about border security. We can talk about remote location institution where physical boundary is not possible. Okay. Just like in JNK, because currently I am working in JNK, so a lot of institutions are surrounding the mountain. So at that location, the physical boundary is not possible. So using virtual fencing, we can monitor boundaries without human intervention. Second thing, we can auto detect routine activities and security breaches. For example, for military application, so we can detect if there is any kind of security breach. Similarly, real-time location specific threat information. Sometimes there are some factories where we are generating critical chemicals. So where at that critical location, the threat is security is very important. If there is any kind of threat, we can identify that threat immediately. Similarly, we can use various sensor technologies for comprehensive security, surveillance. And here, adopt changing environmental and operational conditions. This is a survey kind of paper. We have done a survey. Yeah, this is survey paper. We have not implemented anything yet. We are trying to implement. So if we talk about methodology.
Proposed design.
Yeah, proposed design. Okay. So we deploy sensor as well as cameras at our location, our area of interest. From that location, we are getting the data, and that data is transferred to central computer for processing. Central computer process the data, and based upon process data, the computer identify whether there is a threat or not. If there is a threat, then it will generate an alarm system, and using alarm system we can do loud warning and automatic log. Similarly, if there is a security team, so we can investigate and call authorities. So some of the application of virtual fencing are military origins, technological producers, and civilian commercial or adaptation. Similarly, we can use various AI technologies for evolution of virtual fencing. So if you talk about types of virtual fencing, there are three kinds of virtual fencing. This is based upon electromagnetic virtual fencing, sensor-based virtual fencing, and last one is GPS or geofencing technologies. So if we talk about electromagnetic virtual fencing, it is invisible boundaries using magnetic field, and from magnetic field we can generate low power electronic signals, and that signal identify if there is any attack or there is kind of threat, and based upon threat we can protect our area. Similarly, if you talk about sensor-based virtual fencing, so here we are using various motion sensor, we are using infrared detection system and various video analytics for identifying the threat. Similarly, GPS-based system, here we are using GPS or GIS for identifying various kind of threats. So there are three technologies are used. First one is major technologies, sensor technologies. Second one is communication protocols, and third one is artificial intelligence. So sensor technology is based upon sensor, microwave, motion detection, and optic sensing system. Similarly, if we have better technology, communication technology, so we can transfer data from one location to another location using edge computing, and we can easily process our data. Similarly, we can use AI. So based upon AI, we can detect in accurate manner the threat. We can detect the threat in accurate manner, and after detecting, we can create these signals, or we can create an alarm. So here, sensor technology, it works like the ear, or you can say eye. So based upon sensor technology, sensor data, that data goes from one location to another location using edge computing. And using edge computing, we are using AI and machine learning. And based upon AI and machine learning processing, we can identify the threats, whether there is a threat or not. And based upon that threat, we are communicating our information to generate an alarm system. So these are some of the major applications of virtual fencing, that is military and defense. We are using it in industrial and commercial purpose. We are using it in environmental conservation, and we are using for transportation and infrastructure. So for military, there are simply critical infrastructure protection. Some are restricted areas where nobody can go. Okay. So these are the challenges that we are facing. That is cost and infrastructure, that is privacy and ethics, technical challenges, and geographical and environmental constraints. So if you talk about geographical and environmental constraints, there may be some different terrain, there may be some uneven landscape, and there are some harsh weather conditions. So these are the challenges. If you talk about technical challenges, so reliability is an issue, then potential vulnerability is an issue. So these are some of the challenges. So these are the future direction and research opportunities. Here we can work more on AI. We can integrate our system with IoT-based system, and we can use more advanced sensor technologies. Similarly, we can use more adaptive and dynamic security systems. So from our survey paper, these are the key takeaways. We can enhance security. Virtual fencing provide more comprehensive and intelligent security system compared to traditional security system. And here we have more adaptability and flexibility. Virtual fencing can be easily deployed anywhere in a dynamic manner. Similarly, there is more. If we talk about in the long run, the virtual fencing is a very cost-effective as compared to the traditional system. So these are the references. Thank you so much.
What is the expected cost reduction with respect to the physical fencing?
Yeah, madam, if you talk about physical fencing, then we have to create physical boundaries.
Expected cost reduction in percentage.
Yeah, percentage means we can say about 25%.
You have estimated the cost?
Yeah, we are expecting, but we have not implemented.
You will be using the AI algorithms, will it be supervised?
Yeah, it is supervised.
And since the terrain is multi-terrain,
Yeah.
so will there not be any issues of communication?
Yeah, there is a challenge we have to solve. We have
How will
to.
it impact your virtual sensor?
So, madam, there may be some
Effectiveness of virtual fencing.
they may be reduced. But actually, we are working. This is part of project.
It's a proposal.
Yeah, proposal. That proposal is accepted, but we have to work on that. Thank you so much.
Thank you, Mohammed Naseem. That brings us to the end of session 2. On behalf of the conference organizers, I extend my gratitude to our session chairs, Dr. Maniza Hijab and Dr. Abid Sanwani for their guidance, and to all the presenters for sharing their insightful research. I would like to call Professor Dr. Pradeep Kumar, Head of the Department CS&IT, to present certificate to Dr. Maniza Hijab.
I request to give pose once again. Maulana, please join the frame. Jamil sir, आइए. Even I was caught.
मैं समझ गया था एक आपकी तरफ
आओ जल्दी.
Sir, please.
Madam is giving me.
सबको कवर कर
खाली
चलिए आ जाओ
आ जाओ सर.
अली सर, अरे आगे बैठ जाओ नहीं तो.
फोड़ गया भाई पानी पीने थक गया यार थक गया
Thank you.
Thank you, sir.
Thank
क्या
you.
समझाइए
And sir, I also request you to please present the certificate to Dr. Abid Sanwani, sir.
कितना जो था जमी होता
आइए सर, आइए आइए ना आइए आप.
Islam sir,
Islam sir, Islam.
you can join us.
इस्लाम साहब कम दिस कम ये कितना मैं इसमें अरे इनकी बस
नहीं सर, Islam से दे रहे हैं तो. Sir, frame is.
You also can have a photograph, right? Next one.